6-4 notes. In this section, we'll be talking about geometric sequences. The first definition says geometric sequences, a number sequence formed by multiplying or dividing a fixed number to each previous term to find the next term. So this is a pattern of numbers that is either multiplying or dividing to get to the next number. And that multiplying or dividing term, whatever that's doing, is we refer to it as a common ratio. And we talked about this back when we talked about arithmetic sequences. Very similar, but this time instead of adding and subtracting like we did with arithmetic, now we're either multiplying or dividing with geometric sequences. So I think we called it a common difference in arithmetic. Now it's called a common ratio because when we say what it is either multiplying or dividing by, every time we need to say it is multiplying by something. Now, well, what if it's dividing by something? We're going to say it's multiplied by a fraction. So we'll practice that a little bit when we look at some examples, but for example, it could be multiplying by 2, multiplying by 3, multiplying by 5. Any of those options could be a common ratio. But if we see something that says divided by 2, we're going to actually write it as times 1/2. Same thing if it was dividing by 4. We would say it's multiplying by 1/4. You're going to always say it as multiplying by 1 over whatever it was dividing by. Now, we've talked about a sub n in the past. We actually are probably going to use it as a g. Since we're talking about geometric instead of arithmetic, I might refer to it in some examples as g of n instead of a of n. It's the same thing, just a different name. So that a sub n or g sub n is just a notation that we use when we're talking about sequences. Now there's two different equations we can use for geometric sequences. There's recursive and there's explicit. Now this semester, we're just going to focus on this explicit formula down here. It's basically saying that you take the first term of the sequence. So whatever that first number is, a sub 1 or g sub 1, you might see it as, and you're going to multiply by that common ratio. So we have whatever it was multiplying by, and that exponent is going to be n minus 1. So we're going to use this in order to make some equations and possibly find like the 27th term. It will help us to find any term number in the sequence instead of continuing that pattern as far as we possibly can. So let's look at some examples together. Okay, so this first example right here says, given the following, a sub 1, or we could say g sub 1 equals 5, and r is 2. So this sequence tells me it's starting at the number 5, and every single time it's multiplying by 2. Then after we find that out, we're going to find a sub 7, or I'm going to say g sub 7 actually. And remember, we're just going to focus on that explicit formula this time. We're not going to really look at the recursive. So that rule or that equation for explicit was g sub n equals g sub 1 times r to the n minus 1. Now what's really nice about this equation is once we plug our numbers in, we're going to leave it exactly how it is. We don't have to simplify anything. So my g sub 1 was 5. So my equation is going to be 5. And in parentheses is going to be my r, or my common ratio, which was 2. And my exponent is n minus 1. So there's my equation right there. I don't have to do anything else except for put those in the correct spot. What I do need to do is to find my 7th term. So g sub n, or g sub 7, I'm going to plug that 7 into the n in my equation. So 5 times 2, and then the exponent is going to be 7 minus 1. Or we could say 5 times 2 to the 6th power. Now we can type that directly into our calculator, which is really nice. And when I type it in, 5 times 2 to the 6th power, or to the power of 7 minus 1, it gives me 320. So instead of multiplying by 2 as many times as possible, I just was able to plug it in my calculator with that equation. All right, let's look at another example. This time we're given some different term numbers. So this time it says G sub 1, they said A, same thing. G sub 1 is negative 282, and my common ratio is 1/3. So that tells me that I was starting at negative 282, and every time this was dividing by 3 or multiplying by a 1/3. So let's write our explicit formula. So remember that explicit formula is that G sub 1 times R to the n minus 1. Or A sub 1, whatever letter you want to use, they kind of can use either one. Okay, so I'm going to put that negative 282 in the front because that was the first term. And then my common ratio is going to go in parentheses, 1/3. And my exponent for the equation is just going to be n minus 1 because that means it's the equation that works for everything. Leave the n as n. When we want to find our 12th term, like it's asking for down here, or G sub 12, A sub 12, whatever you want to say, we're going to plug that 12 into the exponent. So negative 282 times a 1/3 to the 12 minus 1. So I can plug that directly into my calculator. So when I type this in the calculator, negative 282 in parentheses, a 1 divided by 3, and then the exponent up there, there's going to be a 12 minus 1, or you could put it as 11, whatever you're feeling. Now, when I hit enter, it's going to give me this long decimal. And remember, decimals we do not want as our answer because then we have to round them. So if we use our calculator correctly and we use that math enter, it will give us a fraction. So it looks like our 12th term was this crazy fraction of negative 94 divided by 59,049. So some crazy big fraction, but it is our answer. Alrighty, looking at the next example. So now they're actually giving us a sequence. We need to find those two parts of the equation to use to find any term. So it looks like it went 8, 4, 2, 1, 1/2. It's going down, which in my mind, if we're either multiplying or dividing, that means it would be dividing. So I see to get 8 to 4 to 2, it was dividing by 2 every time. But we do not want to say this as division. Remember on that first part when we were doing the definitions, we want to say this as multiplying every time. So this is the same thing as saying it was multiplying by a 1/2 every time. So that is our common ratio, 1/2, what it was multiplying by every time. And our very first number in this sequence was a positive 8. So that is our A sub 1 or G sub 1, whichever way you want to say it. So let's write our explicit rule. I'm not going to write that recursive one. So remember that is G sub n equals G sub 1 times R to the n minus 1. So I'm going to plug what I got into that explicit formula. So the 8 is going to go in front. And then in parentheses, it's going to be 1 divided by 2. And then my exponent is n minus 1. And I don't have to do anything else. I can leave it just like that. Alrighty, last example. We are writing that explicit rule again. So let's see what our pattern is. We got a 1/4, then a 1/2, then a 1, and then a 2. It looks like it's getting bigger over time. And if you're not sure about these fractions, you can always look at those whole numbers to start off and see, well, I know to get from 1 to 2, I would have to multiply by 2. Well, if you check the rest of them, it also is multiplying by 2 every time. So our common ratio is a positive 2. And our very first number of this sequence, our A sub 1 or G sub 1, since this is geometric, would be a 1/4. So let's write that explicit rule. Let's plug it into that equation exactly where they're supposed to go. So our very first term was 1/4, so that's going to be in front. And in parentheses, we're going to have that positive 2. And then our exponent is n minus 1. And we can leave it just like that. in order to find any term number we possibly could want.